Are you ready? It's time to review. Woo! You can do it. Alright, so I just wanted to give you guys a little music to get you pepped up and hopefully get you ready for this review. Alright, first question that we have here is graphing the functions. So what you want to do is make sure that you make tables. So the first thing we're going to do, and I apologize for the squeaking, but the first thing we're going to do is make two tables. So you notice that the first table is going to be made up of numbers that are greater than 1. So we'll call this the greater than table. And we're also going to make it closed because remember there's an underline underneath the greater than, which tells you that it's the close. The first point will be closed. The second one will be less than, and that'll be open because the first value here at 1 does not have a line underneath. Doesn't have a line underneath here, so it's going to have an open value. So now we pick two numbers that are going to be greater than 1. One always starts it because we have to have that first point on the graph. And then we pick two numbers that are bigger than 1. So then you just plug it in. 1 times negative 3 is negative 3 plus 2 is going to give you negative 1. Then we do it again. 2 times negative 3 is negative 6 plus 2 gives you negative 4. And then 3 times negative 3 is negative 9 plus 2 gives you negative 7. Making your first values at 1, negative 1, 2, negative 4, and 3, negative 7. Now, the second table, the open table, has to pick numbers that are smaller than 1. So numbers that are smaller than 1 would be 1, 0, and negative 1. So now we're just going to plug in those values. 2 times 1 plus 4 is 6. 2 times 0 plus 4 is 4. And 2 times negative 1 plus 4 is 2. So now we have the points at 1, 6, 0, 4, and negative 1, 2. Now to graph. First one, the closed one, we're going to go to 1, negative 1, and make a closed circle. Then we're going to go to 2, negative 4, and still make it closed. And then go to 3, negative 7, and still make it closed. Remember to highlight your domain restriction because you know that your graph should have one line going to the right of the highlight and one going to the left. Okay, I know my line's not super straight, but hopefully you guys will have a straight edge. Now for the other graph, we're going to go to 1, 6, make an open circle. Then we're going to go to 0, 4, and that will be closed because that's included in the less than 1. And then go to negative 1, 2, and that will be closed as well. Connect your dots, and there you have it. Alright, the next one, we're going to make two tables again. We want numbers that are smaller than 3 for this table, and this one's going to be closed because there's a line underneath. So numbers that are smaller than 3 are 2 and 1. For the other table, the open table, we want to pick values that are bigger than 3. But remember I told you when you have a 1/2, you want to try to pick numbers that are even, because you want to get numbers that you can divide into or multiply to 1/2 that won't give you any decimals. Problem is, 3 is part of our domain restriction, so we have to have 3 as one of our values. So you'll have one value that has a decimal, but the other two you don't have to. So numbers that are bigger than 3 that are even would be 4 and 6. Those are nice even numbers that you can pick that won't give you decimals. Now, do you have to pick these numbers? No, you can pick any number you want that's bigger than 3, but just make sure that you know that if it's an odd number, it's probably going to be a decimal. Okay, so plug in 3 into 2, and you get 2 times 3 minus 2, which is 4. And I know this is kind of hard to see. Then we have 2 times 2 minus 2, which gives you 2. And then the last one would be 2 times 1 minus 2, which is 0. So those are your 3 points there. Now in the next one, we have 1/2 times 3, which gives you 1.5, plus 3 is 4.5. The next one is 1/2 times 4. Half of 4 is 2. 2 plus 3 is 5. Next we have 1/2 of 6, which is 3. And 3 plus 3 gives you 6. So those are our values. So now I'm going to take my highlighter and go to my domain restriction, knowing that I should have one graph on the left and one graph on the right. So the first graph is going to be at 3, 4 with a closed circle, 2, 2 with a closed circle, and 1, 0 with a closed circle connecting all of these dots. Next, we're going to go to 3 and 4.5. 4.5 is going to fall right in between 4 and 5. So we're going to make an open circle. Might be kind of hard to see, but it's going to go right in between. Then we'll go to 4, 5, and then 6, 6. And connect those dots. And there we have our piecewise picture. Okay, let's take a look at the next one. It's an absolute value. Remember what absolute value I told you needed to have 3 things. Those 3 things that you need to have for me is vertex, your A value, and then your graph. So the vertex for this, remember, is always going to be opposite of the first number. Second number stays the same. That's your vertex. So the opposite of -4 is 4, and 3 stays the same. So that is my vertex. The A value is whatever number is in front of the absolute value. We have no number in front of the absolute value, so it's just going to be 1. So now we can start graphing this absolute value. We go right to 4 and up to 3 and make our dot. Then since A is 1, we're going to treat that like a slope and go up 1, over 1, up 1, over 1. Now remember, absolute value is a V-shaped graph, so don't continue your line this way, but you're going to reflect that point onto the other side. And then connect your dots. Okay, the next one we have to find our vertex. Remember, the vertex is opposite of this number. Second number stays the same. So our vertex here will be at -1, -2, and the A value, which is our slope, will be -1, 3. That negative is going to carry up to the 1, meaning we're going to go down 1 and right 3 once we start graphing. So go left 1 and down 2 and make a dot. That's your vertex. After you make your vertex, you're going to go down 1, right 3, down 1, right 3. Don't connect the dots in this way because we have to make our V formation, so just go the other way. Down 1, left 3, down 1, left 3. And then when you're done, just connect the dots, making sure that you have a V. Alright, so that concludes, oh no, we got 2 more graphs, alright. Okay, next we have this graph. We have a vertex at opposite and same, so there is no value next to x, so that's just 0. And the negative 2 stays the same. The a value will be 3/4, meaning you're going to go up 3 and over 4. So now just start at 0, negative 2, and then go up 3 over 4. Up 3 over 4. Up 3 over 4. Up 3 over 4. Okay, sorry for that squeaking sound. I don't know how to get rid of this frequency. Alright, so connect your dots. And there you go. Okay, the next one is a step function. Remember with your step functions you have, these are your x values, and this is your y value. Okay, so the first thing we want to do is treat these like coordinates. So this would be the coordinate -3, 4 and 2, 4. Because that's your x and that's your y. So this first one will be an open circle and this will be closed. It's open because there's no line underneath here, but next to 2 there is a line. So now the next thing we're going to plot would be 2, -1 and 5, -1. Then the next one will be 5, -5 and 7, -5. Alright, so now all we're going to do is just connect. We're going to wind up making horizontal lines. So you go to -3 and 4 and make an open circle. Then go to 2, 4, make a closed circle, and connect your dots. Looks like barbells. Okay, the next one will be at 2, -1 with an open circle, and then 5, -1 with a closed circle. Connect those so they look like barbells. And the last one will be at 5, -5, and then at 7, -5. So by the time you're done, you're going to have, it looks like you're going up steps. Alright, so that concludes the main graphing section. Let's move on to writing the function. So when you write the function, you usually need an a value and you need your vertex. Well, in this section, we don't have an a value. So you have to assume for all of these that a equals 1. So you should always start every function with y equals. And then remember from there, it's opposite of the first number. Second number stays the same. So the opposite of -1, you're going to write +1. And then the second number, you're going to write +3. This all stems from the absolute value equation of y equals a, absolute value x minus h plus k. Remember, opposite of h, K stays the same. Okay, the next one, opposite of 2 is a minus 2, so we're going to put minus 2 inside. And then the second number stays the same, so we'll keep that as minus 1. The next one, opposite of 2, would be minus 2. And since there's a 0 there, we could put plus 0, but you know that that's not necessary. Then the last one, you have, again, you could say x plus 0, but that's also not necessary. So you can just leave x by itself inside and then put minus 3. Okay, the next section we're going to do the same thing, but make sure that you identify what your slope is and what your vertex is. So for the first one, our vertex is going to be at 1 and 3. So always write down what your vertex is. Then we're going to find our slope. The easiest thing to do to get the right slope is always to count the slope on the right. Because if you count the slope on the right-hand side, that's usually the direction that the graph is facing. For instance, because this V is facing up, we should count the slope for the line that's going up. Okay? Because usually the other line is just a reflection. So the slope for here, if I make my own dots, will be up 1 over 1, up 1 over 1. So that means my A is 1 over 1, which means it is just simply 1. So now when I plug it back into this equation, just like I did in the last few questions, it would be y equals A equals 1, so that stays blank, x minus h, which is 1, plus k, which is 3. So there's your first answer. The next one, your vertex is at -2 and 3. Your slope winds up going down 1 over 1, down 1 over 1, down 1 over 1. So since I'm going down 1 over 1, that means my slope is -1 over 1, which is -1. So when I put it back into this equation, A is going to be -1, which I can just put as a negative sign in front of my absolute value bracket. And then I do x minus -2. Well, a minus negative, so really it looks like this. When you have two negatives together, it becomes a plus. That's why we put the plus inside the bracket. And then plus k, which is plus 3. Okay. All right, last one. Our vertex is at 0, 4. And then the slope counts down 1 over 2, down 1 over 2, down 1 over 2. So it keeps going down 1 over 2, and because of that, that means our A value will be -1, 2, because negative will go with the top number. So now when we replace that -1 in for, -1/2 in for A, it's -1/2, absolute value bracket, x minus 0, well that means we don't need anything here, and then plus 4. So please make sure that when you're graphing for me on this test, that you make sure that you indicate the vertex and the A value before you write the equation, because I will be looking for all of that when I'm grading your papers. Alright, the next thing is a word problem, and I know a lot of you guys were asking me, how do I graph something that goes as high as 120? Well, it means that you have to change your scale. Changing the scale means you just change your numbers. So I know that I could start at 0. Since my A value is -30 and my vertex is going to be 7 and 120, I'm going to number by 30s. It's going to make it a lot easier for me to count down. So I'm going to go 30 here, 60, 90, 120, 150. Now this axis I can number by ones. Remember that they said that 0 represents 12 p.m. So this is 12 p.m., so this will be 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., 6 p.m., 7 p.m. And I'm going to extend this a little. 8 p.m., 9 p.m., 10 p.m. So now that I have my scale, I can graph it. Remember, you always start at your vertex. So our vertex in this case is 7, 120. And then you're going to count down and over because our A is negative 30. Well, that means we're going to count down 30 and over 1. So if I count down 30 and over 1, I go this way. And then of course I'm going to have to go the other way as well. Then I count down 30 over 1 again. Down 30 over 1. Down 30 over 1. And here's my graph. So the vertex was at 7 and 120. So they said explain what each coordinate in the vertex means. Remember, this area here represents the time that people go to the restaurant, and this part right here represents the number of people that are in the restaurant. So if I'm going to the restaurant and as I'm going, each time it increases with the amount of people. So at 3 o'clock there's really nobody there, but at 4 o'clock there's 30 people, at 5 o'clock there's 60 people, at 6 o'clock there's 90, and then at 7 o'clock there's 120 people. And then at 8 o'clock it goes back to 90, 9 o'clock's at 60, 10 o'clock is at 30, and then at 11 o'clock when they are closed for the evening they have nobody there. Because remember, the restaurant is only open from 4 to 10. So at 120 you notice it's the highest point. That highest point can be looked at in a business as the peak. Okay, so since that's the highest point, what this represents is at 7 p.m. the restaurant serves the most amount of people, which is 120 people. So 7 p.m. is peak time. Okay, that's another reason you can say. Or you can say that 7 p.m. is the time with the most people. Okay, so you can say all of those reasons, but all of those reasons would be correct. Alright, next one is all about evaluating. Okay, sorry for the squeaking again. I wish I knew how to get rid of it. Okay, it's all about evaluating and knowing which one goes with which. So the f function is going to be all here. The h function, we're going to look here. And the g function, we're going to look here. Okay, so the first one says f of negative 4. So I know that negative 4 is smaller than 3. So it has to be in that category. Since it's only a negative 1, I know that I'm just going to put negative 1 as my answer. Okay, don't plug anything in. Because -1 is what we call a constant, and there's no variables for you to plug in. Don't plug anything in. Just leave it alone. Okay, the next one is h of -6. So we're going to plug in -6 into this equation. So what you're going to do is plug in, keep the negative on the outside, plug in -6 in for x, close the bracket, and then plus 3. What you have to remember about absolute value is absolute value takes any number and makes it positive. So if you have a negative number inside, it equals a positive number. If you have a positive number inside, it's still positive. Absolute value stands for distance. It's how far something is from 0. So when we work this out, we get -8 inside. Well, -8 is 8 units away from 0 to the left. So we're going to change that -8 absolute value to equal just regular old 8. Now this negative from the beginning stays with the whole problem. Okay, that negative is kind of like multiplying -1 to that 8 on the outside. So don't think that a negative and a negative equals a positive. It doesn't work in this case because this is absolute value. So we took the absolute value of -8 and changed it to +8. Now we take this negative from the outside and apply it. So -8 plus 3 is going to give you -5. Alright, let me just separate this question. Okay. Alright, so now the last one part. We have g of 6. Well, we know that 6 is bigger than -1. So we're going to replace it into that equation. So it'll be -2 times 6 minus 3. So -2 times 6 is -12. Minus 3 is -15. Alright, we got 3 more. Okay, so I just highlighted which ones go with which equation. So g of -2, we know -2 is actually smaller than -1, so we're going to plug that into the first one because -2 is smaller than -1. So you'll have -2 plus 3, which is 1. Okay, now we have our f functions. So f of 4 falls in between here. So we're going to replace 4 into that equation. So -3 times 4 is -12, plus 2 is -10. Okay, the last one says 6. You know you're looking for the equal to sign, so it falls into this category. So we have 2/3 times 6 minus 3. Now, you guys are probably looking at fractions like, how do I deal with fractions? So what you do is always multiply the top. So 2 times 6 is 12. Then you're going to divide by 3, which gives you 4. So always multiply the top first. Once you get that answer, divide. So 12 divided by 3 is 4. And now we take that 4 and subtract it to 3. And we get an answer of 1. Alright, the next two that we're going to do is writing piecewise. We have one very interesting piecewise equation here to write. Don't worry about 22. You won't see anything like 22 on the test. You just really have to be comfortable with something like 21. In grading your quizzes, I saw that some of you were not a little comfortable, so please make sure you come in for help. Alright. First things you have to do is always identify your M and B's. You guys lost a lot of points on that on your quiz because you forgot to do it. The M is your slope, how far down and how far over you're going. And your B is your y-axis, y-intercept. Where does it cross the y-axis? So if I look at the first equation on the left, I see that it starts you see that it goes up to 1, 2, 3 on the y-axis. So because it's at 3 on the y-axis, you're going to say that B is 3. Now if you start counting, it goes down 1 over 1, down 1 over 1, down 1 over 1. So because it goes down 1 over 1, your slope is going to be negative 1 over 1, which is negative 1. Now on the other side, it never goes up and over, so our slope is just going to be 0. That's a horizontal line. If you were to keep on going to the left to see where it would actually cross the y-axis, it crosses the y-axis at 2. So that means that you have two different equations. Always start with f of x equals. Never forget this part. Our first equation is negative 1, or negative x, plus 3. Your domain restriction is if x is less than, because we're on the left-hand side, and then we want to see what it has to be less than, so we count to the right. 1, 2, 3. So x equals 3. So it has to be less than 3. Because it's an open circle, it's just going to be less than 3. No line underneath. Now the next one is just at 2, because it's a horizontal line, and it's going to the right, and it's colored in, so it'll be greater than or equal to 3. Okay, so don't forget your M and your B's, because if you forget your M and B's, you're going to lose a lot of points. Alright, this one was a special one. It was supposed to connect up here, but it didn't. So in this case, you're going to have two different domain restrictions. You're going to have one at negative 2 and one at 0. Okay, you will not have one like this on the test, but hey, let's practice something with a challenge. So our M, first we can get our M. If I make some dots, it looks like it's going up 2 over 1, up 2 over 1. So since it's going up 2 over 1, my slope is 2. Now for me to get my y-intercept, I have to keep counting up 2 over 1, up 2 over 1. And surprisingly, it's at 1, 2, 3, 4. So if my line extended, B would be 4. Now on this side, the M is going up 1 over 1, up 1 over 1. So that means your M is just simply 1. Now I'm going to see that the B is right here at 0 and it has an open circle. So when I write my equation, I have the first one, which is 2x plus 4 if x is less than this number, which is -1. No, -2. And I'm going to put the line underneath because that's colored in. Now on this side, it will be 1x plus 0, or just simply x. And that's if x, because it's not colored in, is greater than 0. Notice I have two different numbers because I have two different domain restrictions. On your test, you have to know this, okay? It's going to have one domain restriction on your test. So don't get used to this. This is just a extra special problem, okay? All right, we're almost done. We're almost done. Woo! Okay, so now we have a word problem. In May 2003, Nicker Gas had the following rate schedule for natural gas usage in single-family residences. The monthly customer charge was $6.45, and then the charge per therm is the unit for the natural gas. It's like a, it's like saying a temperature. So the charge per therm was, the first 20 therms was 20 cents per therm. The next 21 to 50 therms was 11 cents per therm, and then over 50 therms, it was 4 cents per therm. All right, when it says write the function rule, that's your f of x. So we have to represent the first 20 therms, so that's 20 cents per. So all of these should have an x next to it. So we're going to have 20 cents x plus the charge that we have to charge all the time. So plus $6.45. And that's if your x value is going to be up to the first 20, so it's going to be less than or equal to 20. Then it's going to be 11 cents a therm. Don't forget your monthly charge. And that's if you go from 21 to 50. So if you go to 21 to 50, that's bigger than 20. So we're going to put the 20 in. So 20 is less than, and then less than or equal to 50. You want to try to keep these the same. Okay? You want to try to keep these the same. So if you keep these the same, saying 21 is the same thing because you don't have an equal sign there. Okay, the last one would be 4 cents plus the monthly charge. And we have to go over 50, so it's greater than 50. No equal sign because we already used it for the last one. So make sure that these match up and make sure that these match up. Make sure that if you have an equal sign here, you don't have it here. And make sure if you have an equal sign here, you don't have it there. All right, so what's the charge for using 40 therms? So 40 falls in this category. So we're going to use the second one. So we're going to say 11 cents. Make sure you use cents because a lot of times you guys did not use cents and you messed up on the quiz because you forgot that these were all decimals. So it would be 0.11 times 40 plus 645, which gives you $10.85. Now what is the charge for 15? 15 falls in the first category. So we're going to do 0.20 times 15 plus $6.45. And that gives you $9.45. So for word problems, the big thing is to know how to set them up and to know which one you're going to plug them into. Don't forget your let term, because I did take off a point because you have to identify what your x is. All right, and also don't forget your dollar signs. All right, last question. Woo! Party people in the house. Okay, I'm gonna stop singing. All right, a digital scrapbook company charges a $5 binding fee plus $1.99 per page for up to 10 pages. If you order more than 10 pages, they charge the $5 binding fee plus $1.89 per page. Write a piecewise function for a scrapbook from this company. So always start with your f of x. So it's a $5 binding fee plus $1.99 per page. Once you see per, put the x. So it's $1.99 x plus 5 for up to 10 pages. That means we include the 10. So it'll be less than or equal to 10. Then they said it's $1.89 per page, so make sure that x goes there. Plus your $5 binding if it's more than 10, so don't include the 10. So make sure these numbers match and make sure only one of them has the line underneath. So the first one says, how much does it cost for a 5-page book? Well, 5 falls into the first category. So we're going to plug in 5 into that first one. Okay, so $1.99 times 5 plus 5 will give us $14.95. Okay, the next one is how much does it cost for a 25-page book? It falls in this category. So put 25, and you wind up spending $52.25. Okay, so make sure you always remember your dollar signs. Show me that you plugged it in. Show me all this. And remember your let statement. You have to identify what X means. Also remember that if your answer, like on the quiz, your answer came up to this, most of you put $32.5. That doesn't exist. Make sure you put a 0 at the end there, because it's really $32.50. Okay, we're done. Okay, we're done. Woo! Okay, hope this helps you out. Make sure you look at this. Sorry for the squeakiness, but I really hope it helps. All right, good luck, everybody.